Hello, have you ever thought about how our universe will end? In this video, we'll be helping you through the different ways it could potentially happen. To start off with, we'll introduce you to 3 key terms associated with the cosmological principle. These are important and fundamental when considering the larger scales of the universe. To start off with, we have homogeneity. On the larger scales, the local universe has the same physical properties throughout the universe. This can include mass density and expansion rate. Second, isotropy. On the larger scales, the local universe looks the same in any direction one observes. Universality. This is when the laws of physics are the same everywhere throughout the universe. Right, so before we get on to how the universe might end, let's quickly discuss the current state of the universe. We know that the universe is currently expanding. This is because light from other galaxies except one is redshifted. This shows that they are moving away from each other. When this is mapped onto a graph, we can find Hubble's constant h0, where v is velocity and d is distance. This is the Friedmann equation. R is the scale factor, K is the curvature, and capital lambda is a cosmological constant. You don't need to know this, except for the fact the solutions to this equation give 3 models of the universe that we will discuss: open, closed, and flat. The fate of the universe largely depends on matter density in the universe. If the density is equal to the critical density, then the geometry of the universe is flat. If it's greater than the critical density, then it's open. If it's less than, then it's closed. So what is critical density? Critical density is the average density of matter needed for the universe to halt its expansion at infinity.
Firstly, let's consider an expanding universe. The density of an expanding universe is less than the critical density, giving a density parameter of less than 1. This means that gravity will not stop the expansion, as there is not enough mass for gravity to have a significant effect. This gives the expanding universe an open geometry, so if 2 photons were fired parallel from one another, you would eventually see them diverge. From observations of Type 1a supernovae, it is possible to see that the rate of expansion of our universe is in fact increasing. So why aren't we certain that this is the universe we are in?
Now we will consider the flat universe. The density is equal to the critical density, giving a flat geometry. This means parallel lines on this universe would always remain parallel. A flat geometry suggests that the expansion of the universe has been slowing down since the Big Bang due to its own gravity. After a finite amount of time, the size of the universe will remain constant. Physicists around the world believe this is the most likely state of our universe, as cosmic acceleration can be explained by the cosmological constant. Energy corresponding to this can account for the missing mass required to produce a flat spacetime. This is called dark energy, which is a force that permeates throughout the universe and causes it to continually expand at an accelerating rate. You can think of it as a bit like anti-gravity. Where gravity pulls things together at a smaller level, dark energy pushes them apart on a grander scale. Further evidence of a flat universe comes from cosmic microwave background radiation, or CMBR. If the universe was perfectly homogeneous on all scales at the time of reionization during the Big Bang, then the CMBR should be perfectly isotropic over the sky. However, it shows small-scale fluctuations, the angular size of which indicate a flat geometry.
Another model of the universe is the collapsing universe. Now the density is greater than the critical density. The collapsing universe has a closed geometry, e.g. like the surface of a sphere. So 2 parallel lines will eventually converge. The expansion of the universe will be slowed down and will eventually stop after a finite time, due to the mutual attraction between galaxies. The universe will start to contract and collapse in on itself to form a final singularity. This will cause a big crunch. An interesting theory following this is the universe is repeatedly expanding and collapsing, creating the big bounce, rather than the big crunch as demonstrated. What do you think is going to happen? Please comment below with your thoughts, and if you enjoyed the video then give it a like and please subscribe to our channel below. Thank you for watching.